In 1903, there were 2 aeronautical engineers in Dayton, Ohio. It would have been hard for the Wright brothers to envision the development of the helicopter, jet propulsion, supersonic flight, and manned space flight. Technical progress and surprise have characterized our century, and without question will continue into the next century. Air Force Systems Command offers science and engineering people an unparalleled career opportunity. For the first time in industrial history, a science or engineering graduate coming into the Air Force or Federal Civil Service will be trained to manage a multi-million-dollar program. After a brief apprenticeship, they'll assume program management responsibilities on a one-to-one basis with their industry counterparts, though they may be 20 to 30 years their senior. At this point, they can draw on the combined experience of their engineering team, developing their expertise and management skills in a dynamic earn-while-you-learn atmosphere. This is only the beginning. For both civilian Federal Service and Air Force people, there are many advanced degree opportunities. Our master and doctoral degree program offers the graduate the chance to be among the most highly educated cadre of scientists and engineers anywhere in the world. Let's look at a case in point. Today at Wright-Patterson Air Force Base, the Deputy for Engineering's 1,500 people carry out the AFSC mission with its greatly expanded new technologies. They provide technical direction for the development of Air Force aeronautical systems, subsystems, and equipment. From its inception, the Deputy for Engineering has developed all Air Force aircraft. The deputy engineers, the engineering force, have evolved into the free world's unique core of technical expertise that spans all areas of aircraft weapon systems development. This is a unique opportunity for both military and civilian science and engineering people. The challenge? Career advancement, involvement in the exploration of technology. Facilities are among the finest in the world. Technical development of billions of dollars worth of equipment annually. The deputy is organized into 3 directorates, which oversee the development of airborne avionics, flight systems, and support equipment. The Directorate of Avionics Engineering is responsible for developing the electronic devices used in military aircraft. These include systems to accomplish navigation and guidance, weapon delivery, reconnaissance data collection, electronic warfare, command and control, and advanced displays to help the pilot aim, track, and guide a weapon, or to see at night. Technical direction and engineering management in the areas of flight technology, structures, propulsion, and flight equipment are provided by the Directorate of Flight Systems Engineering. One of the biggest responsibilities is the support of an aircraft weapon system. The Directorate of Equipment Engineering develops the multitude of equipment needed to support an aircraft and to keep it flying. The equipment designed by this group ranges in size and complexity from a simple test stand to the world's largest fire truck. vehicles that can routinely load or unload up to 40,000 pounds of cargo. They also design equipment to support other services, such as aerial delivery of supplies to Army and Marine Corps units. A significant part of the Equipment Engineering Directorate's efforts are expended in human factors testing. This discipline ranges from ejection seats to testing of all avionics and flight system designs to determine how well people can use the new equipment, and assessing the equipment's psychological impact on the users. Complex simulators have been designed to train crew members to fly all aircraft, spacecraft, and helicopters, and to become proficient in mastering specialized subsystems. In the crew station design facility, engineers and psychologists evaluate future cockpit and space station designs for maximum crew comfort, performance, and utility. The Wright-Patterson community affords the deputy engineers access to some of the most modern scientific equipment, including that managed by the Air Force Wright Aeronautical Laboratories. To accomplish their mission, the deputies engineers fully exploit the excellent research and development facilities available for designing and testing each piece of aircraft and crew equipment. Support from other base organizations also permits these engineers to develop for themselves equipment that is not readily available. While most manufacturing of new flight systems is done by contractors, in-house research, development, and ingenuity have produced systems, such as an airborne C-5 Minuteman ballistic missile launch, an ejection system that lessens the effect of wind blast on ejecting pilots, and a boom operator part-task trainer to train tanker crews in a simulated aerial environment. The Deputy for Engineering is the Air Force's developer of new aircraft systems and is extensively involved in the modification of existing systems as well. An extremely important development tool is the building of aircraft prototypes and the subsequent fly-off competitions. This allows the testing of advanced techniques that can be used on future aircraft designs. In the competition to build a new system, the deputy's conclusions regarding each system's technical acceptability are the most important factors considered when making a final decision on which weapon system to procure. The most important job of the deputy's engineers is to tie together all the technologies and subsystems and integrate them into a single aircraft system. This is a highly complex task, requiring engineers whose abilities cover many disciplines. They must ensure the airframe and engines are sized correctly. The wing is properly designed to carry various weapons. And the radar system is realistic for the aircraft. The integration engineer plays this vital role in putting the entire system together. Through an exhaustive testing program, products are systematically evaluated to assure compliance with structural and dynamic requirements. While most tests are to ensure proposed systems and subsystems meet performance objectives, others are more experimental. These are learning experiences to see what happens under certain conditions, which helps build better future aircraft An example is the deliberate crash of this unmanned DC-6 to help us improve aircraft safety. Effects of the Deputy for Engineering's research and development efforts are far-reaching. 8 of 10 commercial free-world jets are designed and built in the United States. Most trace their lineage to military aircraft programs, such as supersonic technology from the XB-70. In all, 35 of the 51 significant advances in aviation since 1935, such as the swing wing, pressurized aircraft, automatic landing, air-to-air refueling, automatic navigation and retractable landing gear, are products of the Deputy for Engineering Research and Development. The nature of the Deputy's work requires the engineers to remain abreast of the state of the art, often involving work on the frontier of aircraft technology. In addition, they apply lessons from experimental technology, such as this 1950 hovercraft, to new systems, such as this air cushion landing system. The Deputy's close association with many outstanding universities keeps the educational level of its engineers high and encourages a continuing flow of innovative ideas. As a result, engineers in the Deputate have been granted large numbers of patents and have received many of the nation's highest aviation awards, which have won the organization recognition and respect from its peers in the scientific community. As it looks to the future, the Deputy for Engineering anticipates continued involvement in the development of a cruise missile carrier aircraft, an advanced cargo aircraft, laser and charged particle beam weapons, and advanced fighters, as well as continuing efforts to enhance the capabilities of existing aircraft systems. For as long as is necessary, the Deputy's engineers will continue their tradition of researching, developing, testing, and evaluating the aircraft systems necessary to preserve our nation's way of life.